Okay, so today we're going to go over the derivatives of other inverse trig functions. And in our last lesson, I gave you the derivative of arcsine. So I'm just going to write that in here. Hopefully this is one you were memorizing from the last lesson. And this should, that should be with respect to x of any angle. Now I'm doing sine. I don't know where tangent come in. This is what you had. It's 1 over the square root of 1 minus u squared du over dx, where the absolute value of u is less than 1. So we spoke about how there is a restriction, and for some of them there are. Okay, and the reason for that restriction has to deal with when you're working with square roots. So you're going to notice, and hopefully you're copying this down so you can start to memorize, for the derivative of inverse tan or arctan of u, it's just 1 over 1 plus u squared du over dx. And the reason there isn't a restriction is because we don't see that square root. So whenever you do have to have a derivative of a square root, what's underneath cannot be negative, all right? It's got to be a real number underneath. And it can't be 0 because we can't divide by 0. You're not going to end up with something like that happening in the first one we're still talking about over here because we're squaring u. So we don't have that issue. That could be negative, that could be positive. There's no way that denominator is becoming 0. So we're good to go. Derivative of arcsecant. You may notice we said sine and tangent. We seem to have skipped cosine. There's only 3 derivatives of your inverse trig functions: arcsine, arctangent, and arcsecant, because the other 3 are cofunctions: cosine, cosecant, cotangent. Okay, so as long as you know sine, tangent, and secant, you can get the other 3. And I'll go over an example with you. Okay, you would need to know this, and the important thing is what I have here in red. So since they are cofunctions, okay, there's a relationship between them. Okay, like sine and cosine are cofunctions. Okay, if you're working with the sine of pi over 6, it equals the cosine of pi over 3. Okay, because they're cofunctions. And what do you know about pi over 6 and pi over 3? They add up to pi over 2. So you have to write this expression first before you take the derivative. Again, I'll do an example with you. Okay, but first we have this example here. A particle moves along the x-axis, so that its position at any time t is greater than 0 is x of t equals the inverse tangent of radical t. What is the velocity of the particle when t equals 16? Always substitute at the end. So we're going to take x of t. It's not s of t, it's x of t. So x prime of t is velocity. So that means that we do need to know the derivative of arctangent or inverse tangent of our angle here. Our angle here is radical t. So here we go. We need the 1 over, okay, and it's 1 plus u being the angle, and that would be radical t, but it gets squared, and you have to multiply by the derivative of our angle with respect to not necessarily x. So since the variable here is t, we're taking the derivative with respect to t. So the angle that we're talking about, u, is really t to the 1/2 power. So if we take the derivative of that, it's 1/2 t to negative 1/2 power. And we're going to simplify our first fraction and our second one. Okay, so that's v of t. If you want, you can combine them together. But we want to make sure we answer our question. We need to know v of 16 when t was 16 seconds. So if we plug that in, we end up with 1 over 17 and 1 over 8. We'll multiply that out. That's supposed to be an 8. And we get 1 over 136 units per second. That's your rate. Velocity is a rate. Okay? We don't know how many units, like if it was measured in inches or whatever, so we just write units. Done. Okay, if you didn't get the last problem, remember, you need problem work and answer in your notes, so make sure that you stop the video and get it down. These are not to just be looked at, they're to be done at the same time. Just like in class. And so just like in class, I sometimes have more than one example. So example 2, find an equation for the line tangent, we need a derivative, to the graph of y equals inverse cotangent when x equals -1. All right, so here we go. First thing we need to do is rewrite our equation. When it is a co-function, it's subtracted from pi over 2. And what's subtracted by pi over 2? Well, the other side of that. It's cotangent, so inverse tangent is being subtracted from pi over 2. Okay, so remember that part I made you copy? Make sure that you rewrite the function first. Now, we're going to take the derivative. So y prime is going to be, this is actually 0. And sometimes students just memorize the answer to be -1 over 1 plus u squared, and a derivative of u. I was taught that you need to show that you indeed know it's a co-function and you're subtracting it from pi over 2. So I'd rather be safe than sorry and make sure you know this part. Okay, the rewrite of your equation, all right? So at this point, we need to know the slope of the tangent line, but when x is equal to -1. So we're going to plug in -1. Okay, so that's what we need. And if we plug in -1, I lost my page. Here we go. We get 1 plus 1 in the denominator. So our slope of our tangent line turns out to be -1/2. All right, so now that we know that, we use point slope form. And our y equation, I'm trying to get the inverse there, is this. So we're playing -1 there. Here's m, x minus the -1. So this is another one you need to know. So the tangent of what angle is -1? That would be 3 pi over 4. And we plug that in. Okay, as a side note, okay, I'm going to try squeezing it in somewhere. Your range for inverse cotangent is from 0 to pi, excluding 0 and excluding pi. So you need an angle that is within that range, and 3 pi over 4 fits that. Not negative pi over 4, so be careful there, okay? And it's not pi over 4, that would be if it was like a positive one. So now, I know this got kind of sloppy over here, but let me make it look a little bit neater. Once you combine terms, you can make a common denominator for your constants. You don't have to, and if I do, this is my final answer. Okay, and you're good to go. Good luck.